You're welcome, sir.
Yeah, good evening to everybody. Good evening, and you're all welcome to this training today. This training begins today, that is April 15th, 2024. Today, we want to start a new training on machine learning part 2. Then we tag it as deep learning. So, but before we go into deep learning proper, we'd like to brush over the machine learning, do a recap of machine learning again. So my name is Timothy, and I'm the anchor and also part of the trainers for this particular training. So I want to introduce Ayobami Salau, who is to open the floor and start this training from the beginning. So Ayobami, welcome on board.
Okay, sir. Thank you so much, sir. So, good evening, everyone. Good day from anywhere we are. So, and my name is Ayobami. Taking us through the necessary things we need to know about deep learning. So, and there are some misconceptions about deep learning that some of us have, not misconception entirely, that what can it be used for and a lot of things. So, but before we go into the machine learning recap, so I want to note something so we can all be on the same page. So I'll be sharing my screen now.
Hello.
Okay, I think we can all see my screen.
Good evening to you, madam.
Not yet.
Yeah, class is on now.
Okay.
Yes,
We can.
we can see.
Okay, so now the training basically is about deep
First one,
learning
right?
with Python.
And
So,
your
and
login is
the
15K, right?
class is going to be very practical, like I said.
Yes.
So, we're going to be writing a lot of codes showing
Can I share you the link
proper
now?
applications and how it can be used to solve some real world problems.
Okay.
And
That means
there
you
might be some
watch
problems
the video.
that
Right.
in your area of interest, maybe in health, medicine, business, or any area you can apply deep learning. But before we actually go into deep learning, we'll actually go into machine learning. So for a recap, but before then, now there are some things that we are going to do. So I want to prepare our mind. So we are going to learn the fundamental concepts of deep learning. So if you want to know how deep learning works, you must really get to know the fundamentals. It's very vital because if you don't know the fundamentals and the technical know-how of how deep learning actually operates, the logic behind it, then it will be hard for you to be able to choose, okay, when there is a problem, okay, when can I use deep learning to solve a problem? Why must I use deep learning? Actually clarify all those things. So another thing that we need to know is implementation of some deep neural networks in Python. So there are some deep neural networks in Python that we are going to introduce us to, so that we are going to know about. And most especially, like I said, this project, this uh, training is going to be about projects and it's going to be more practical. So we are going to work on some basic projects and we are going to progress to more advanced ones. So we're going to see some things in action. So we're going to see how you can build a computer vision project, by using some of the deep learning architectures like CNN, convolutional neural network, RNN, recurrent neural network, adversarial generative neural network. A lot of them, there are more. So, and we are going to see them in actions. And another thing is, we are going to share the codes on GitHub. There are some, but I will actually try and pull some of them down and sent to us when the need arise. So we're going to have some access to some code. So, and we are going to create a GitHub account for you. I know some of us know about GitHub, and while some people don't know about GitHub. So GitHub is a platform, let me say, for developers or for those that tech enthusiasts, where you can commit your codes or save your codes or any work you do. So it's used for development and a lot of things. So it's used by data scientists, it's used by data analysts, it's used by web developers, front-end developers, and so on and so forth. So that's for GitHub. So it's going to be important that we introduce us to how to use GitHub, so which I will show us. Another one is how to conduct research and publish the result on high quality venues. And there's a reason for this. Now, some of us don't know how to conduct, let me say, research when it comes to area of machine learning and deep learning. So I'm going to show you how to do that, and not only how to do that, but I'm going to show you how to publish your result in a high quality venue. And finally, I'm going to make a curated team. Now, when I mean curated team, means that there are some projects that we are going to give, and which means we are going to pair us in maybe threes or fours. We're going to work together. So, and the project is going to be submitted and is going to be vetted by the instructors, so which I am part of them. I'll vet the project. So I hope we are on the same page. I hope we get what I'm trying to say. So that's one thing I want us to note now. So we're going to talk about deep learning. I'm going to introduce us to different neural networks in Python, and I'm going to show us how to work on some basic projects to introduce us and make us comfortable with deep learning, and then progress into things that are more advanced and sharing of codes, how to use GitHub, so as a data scientist, as a data analyst, and how to conduct research and publish them on a high quality venue. So, and we are going to group our project in a group of four or three, depending on the population. So I hope we get that. Are we on the same page?
Yes, we
Yes,
are.
sir.
Yes,
Okay,
we
good.
are.
All
Yes.
right. So now, this is where I'm going to go to now. Before, there are two materials that we're going to be looking into, and the aspect of the recap of machine learning. And there is something I want us to know about machine learning. So I took my time to do some novel work on machine learning. Okay, I think I'm coming. Is Let me just do this here. So I'm coming. This just want to. Okay, good. So now, we talked about how to do research. Is that not it? So said part of what we're going to train us on how to do is how to conduct research and how to publish them. So, but now, which we'll go into that now in the aspect of the machine learning aspect. So now I'm trying to allow us see machine learning in action here now. This is I took my time because of the recap section. Now it was needed by some people because we really need to understand machine learning before we can go into deep learning, because deep learning is a subset of machine learning. So now we are going to look into machine learning from this aspect at creating a predictive model in machine learning and selecting the best fit based on data patterns. So that's what we want to do. So, and it was documented. It was documented by me. So, and as well, I made this. Yeah. Okay. So I would like to thank all the members of the Timar Programming Consult because this work was made possible by the resources that they disposed. So that's I want to acknowledge them. So and thereby we are going to look at the content now. I made this in form of a research work, so which is in chapter 1 to chapter 5. So the chapter 1 is just the introduction, like introducing the concept of machine learning as a predictive model. The chapter 2, which is the literature review, where we talked about different machine learning algorithms, which is regression analysis. Under regression analysis, where we have linear regression, polynomial regression, and we also have decision tree, random forest, classification methods, as where we have the resampling techniques, example techniques, we have algorithmic modifications, and so on like that. So the chapter 3 is where we bring into play the topic of interest, which is predictive model in machine learning. So for unraveling data patterns. So where we talked about the methodology and the model implementation in chapter 4. So we talked about visual data exploration, feature engineering, machine learning. So where we did an initial model, feature selection, hyperparameter tuning, model retraining, and voting classifier. Then we concluded from the findings of the work. So now, basically, this was the outcome of the work that has been done in this write-up here. So the thing there is this is that significant challenge of model selection amidst the diversity of algorithms and data complexities. Now, this is the reason. Now, sometimes we make the mistake of choosing some certain machine learning algorithm and it doesn't perform well. The accuracy doesn't make sense. And that is because we are not doing it rightly. And when I say doing it rightly, I mean that when you want to actually choose a machine learning algorithm, you need to first understand the data itself, the data complexity. It does matter. So the data actually determines the type of machine learning algorithm you will use. And that's one thing we should note. So we need to note that the data itself actually determines that. So if we don't put that in focus, then we are going to make a mistake of choosing a machine learning algorithm that will not explain the variation in the data, and it will not give us a good model, something that we can use as a predictive model. So in cases where we need applications like businesses and in healthcare and in any other areas like that. So the focal challenge includes establishing selection criteria, mitigating overfitting and underfitting. We're going to look at what overfitting is and underfitting is, and discerning appropriate evaluation metrics. Now, evaluation metrics is something that has to do a lot with machine learning because these are ways that we can actually be able to justify if the machine learning algorithm we are using is actually good or not good. So, or is not performing better. And there is this notion that not all models, no, there's no perfect models, and not all models are bad. But we want the one that can actually give us something meaningful, something we can work with. So, and the study dissects some challenges employing statistical techniques such as cross validation and performance metrics to evaluate models' efficacy. So, and notably, from the preliminary findings, it indicates a promising accuracy of approximately 86%. So, the accuracy I got based on the data that I used. So, the thing there is that we 11 machine learning algorithm was used here. So, we now chose the one that performed better. So, the one that performed better actually for this, actually we voted classifier, but the one that performed better is the Gaussian process model. So which gave us this accuracy, 85%. 0.7%. So the rest are a little bit below this. So that's just one thing I want us to note. So this is just like we are using different machine learning algorithms. Different. 11 was used here, and I'm going to share with us the code. We are going to see the code itself, how it looks like, and how we came about all that. So that's that about that. Now, this material is going to be shared to us, so which we can go through it in our own leisure time. Just and the study here actually gave an exhaustive. If you want to really get to know about machine learning very well, so you can read through the introduction and as well the literature review, and there are a lot of references where and journals that you can actually that is being cited that you can go there and get more ideas on them. But yeah, I can assure you, if you go through this, you get the proper underlying working process of machine learning. So, but here now, where I want to go to, so I won't bore us with all of this. Here is that there's we'll go to the statement of the problem. Now, the thing there is that from the topic itself, we said predictive model in machine learning. What we want to do is we want to select the best fit. That means that we are using numerous machine learning algorithms. So what we want to do now is, okay, fine, we have numerous ML algorithm. What we want to do is we want to choose which one actually explains the variation in a data. So that's what we want to do. So which we defined the problem that is being here. The statement problem is that the selection of the best fit predictive model based on data patterns poses a significant challenge in the realm of machine learning. Like I said, if you want to choose a machine learning algorithm, it depends on your data pattern. So while predictive modeling techniques have advanced considerably, the task of identifying the most suitable algorithm remains complex due to the diversity of available methodologies and the intricacies of data patterns. So there are lots and lots of, let me say, machine learning algorithms that we can tap into, that we can use for any data that we have to build a model, a predictive model. But that is not the case. You can't just, you know, the badge in and start choosing, okay, let me just use this one because you feel like using it. No. Now, there's something you need to know. It depends on the data itself. The data itself is what we actually be the judge of that. So now the several challenges that arise in the process of selecting the optimal predictive model is this. We consider the model selection criteria, which is determining the criteria for selecting the best fit predictive model is not straightforward. So different models may perform differently based on the characteristics of the data set and the objective of the prediction task. So, and we can make reference to these journals. So they give reasons to that. So that different models may perform differently based on the characteristics of the data set. So, and also as well, overfitting and underfitting is also something to consider when you want to build a predictive model. Now, ensuring that the selected model is accurately captures the underlying data pattern without overfitting to noise or underfitting to essential patterns is also crucial, because there are some models that will give rise to overfitting and some will give rise to underfitting based on the data pattern. And now also the evaluation metric is also part. Choosing appropriate evaluation metrics to assess the performance of a predictive model is also essential, but it's challenging as there are different metrics and they can be used suitably for different type of prediction task as well. And also feature engineering. Now, when it comes to creating machine learning models or building predictive models, feature engineering is the core part of it. The process of feature engineering, it's including selecting, creating, and transforming features, can significantly impact the performance of predictive models. You see, this is where you can, if you miss it at this point, which is feature engineering, then the model we are going to have is going to be it's going to perform badly, because feature engineering is part of everything. It's to transform, to do data normalization, data standardization. So all those things are very important, and they affect the model we want to build. So if we can actually spend more time on feature engineering, that is trying to clean our data very well and to structure the data in such a way that it will actually suit the machine learning algorithm, then we can get a very accurate machine learning model on the longer run. So, and also, if we look at hyperparameter tuning, now, when we talk about hyperparameter tuning, optimizing hyperparameters of machine learning algorithm is crucial for improving model performance, but it requires careful consideration and computational resources. That means trying to make sure that you enhance um, the machine learning model you have considered, that's the algorithm you have considered. So now all these things are things that actually we should consider when we want to build a predictive model using machine learning model. You see this model selection criteria, overfitting and underfitting, evaluation metrics, feature engineering, and hyperparameter tuning. They are very important. Are very, very important. So we need to put that in mind, especially feature engineering. So now, what is the aim and objective? Now, I just have to do this in such a way that so we'll get the point. So the main reason why this write-up is tailored is to allow us to have this mindset of a machine learning expert, so that even as a novice, as a beginner, as an expert or an advanced learner, you can build machine learning model independently on your own. So provided you have some things, so the fundamental things that needs to be known. So that's just the thing that is there. So now that's why we said the primary aim is to investigate and elucidate the methodologies and challenges associated with selecting the optimal predictive model based on data patterns in the domain of machine learning. So the objective are as follows: is that to explore and analyze various approaches utilized in selecting the best fit predictive model based on data patterns, to assess the role of statistical techniques such as cross-validation and performance metrics in model selection processes, and to investigate the significance of feature engineering. You can see here we say significance of feature engineering and hyperparameter tuning, enhancing model accuracy and robustness. Now, so spend more time on feature engineering, your model can be very robust. Now, to identify and examine the challenges, including overfitting and underfitting, inherent in the selection of a predictive model. So now, the research question here is that what are the different methodologies and techniques employed in selecting the optimal predictive model based on data patterns? How do statistical techniques, including cross-validation and performance metrics, contribute to the process of selecting the best fit predictive model? What is the impact of feature engineering and hyperparameter tuning on the accuracy and robustness of predictive models? You can see these are questions that need answers. So what are the key challenges such as overfitting and underfitting encountered during the selection of predictive models? And how do they affect model performance and generalization capabilities? So now, I want to, so it won't be like I'm moving too fast or anything. So do we get what I have been saying?
Yes, sir.
Yes,
Yes,
sir.
we are with you,
We get
Ayogami.
Okay.
Okay, so
Yes.
and am I being clear enough? So it won't be like I'm not carrying everyone along. I
You are
just
very audible. Please go ahead. We are recording. You are
okay,
very
sir.
audible. Go ahead.
So now we want to look at the significance of the study, because we are actually trying to study how to create predictive models using machine learning. So, and the significance is that it lies in the pivotal role in advancing the efficacy and reliability of predictive modeling in machine learning. So now there are a lot of people that are out there. They just build machine learning models, just based on they are not grounded. They don't have the underlying knowledge. They just go ahead because they know how to use they know how to use k-means clustering. They use k-means clustering. Now, if you ask them why are you using k-means clustering for this particular data, so they won't be able to explain. And if you ask them why are you using regression, um, regression for this particular data, some people won't be able to explain. So there are a lot of reasons why you should choose a particular model for a particular data, and knowing the reason to that will actually help on the longer run, because when there is an issue or an issue arises and the model does not perform better, then you know, okay, this is what I can do to make sure the model gets more better. Maybe let me go back to feature engineering. Let me see if okay, if I have outliers, if I need to remove outliers. Okay, what of if okay, I need to drop some rows, or if I need to, truncate the data. There are a lot of things you can do. So to enhance the robustness of the data, that's still under feature engineering. So but so that's what we actually need to know. So, and by delving into the methodologies and challenges associated with selecting the optimal predictive model based on data patterns, we want to address a critical gap in current practices. And the gap in current practices is what we want to. So, in an era where data driven decision is increasingly prevalent across industries, the ability to develop accurate and reliable predictive models is paramount. So, therefore, these studies findings have the potential to significantly enhance predictive modeling practices, thereby empowering organizations to make informed decisions based on robust data analysis. So, now the main thing there is this is that there are a lot of organizations out there, a lot of institutions, a lot of bodies that actually deals with data, and data keeps on increasing. So now the effectiveness of analyzing data is what we need. We don't just need people that can analyze data. We want effectiveness. We want models that are apt, that are solid, something that we can say, okay, yes, with this model, I think okay, we are okay, and we can know can make informed decisions based on this model that we have. So that's what we need, and that's why we are trying to do, make us actually realign our ideas and concepts, and actually make us see what machine learning is and what it is not. So now, furthermore, the insight generated from this study have far-reaching implications for various stakeholders involved in predictive modeling, including researchers, practitioners, and industry professionals. So now, by elucidating best practices and strategies for model selection, this research equips stakeholders with the knowledge and tools necessary to navigate the complexities inherent in predictive modeling processes. Armed with this understanding, practitioners can develop and deploy predictive models that not only meet performance requirements, but also exhibit greater generalization capability across diverse data sets and real world scenarios. So that is the main aim. So now, another thing we need to know is that, moreover, the significance of this study extends beyond immediate practical implications to the broader academic community. So, by contributing to the academic discourse surrounding predictive modeling and model selection in machine learning, so this research enriches scholarly understanding and lays the groundwork for future research endeavors. So, if you are thinking of going into a research using machine learning, basically, you can use this material. This material is sufficient enough for you to orientate you and give you this innovative mindset of being a apt machine learning scientist, whereby you can say, okay, yes, okay, with this intricate knowledge, I can build a model that will perform better in the outside world there. So that's just the thing there. So now I don't want to boss more and more. So now let me just go to some things. Now, there are some things we need to set straight. Now, so what we need to define some terminologies. So now, what is predictive modeling? What does that word mean? So predictive modeling is the process of developing mathematical models or algorithms that make predictions or forecasts about future events based on historical data. Now, the main thing is that, you see, machine learning algorithms or models that we are building now, they can't survive without historical data. Now, what are historical data? Historical data are data that has been collected for over the years, and they are just lying there dormantly without any use. And now we want to now make informed decision based on them. So that's the reason for saying we want predictive models. So it involves using statistical techniques and machine learning algorithms to analyze patterns in data and make predictions about unknown or future outcomes. Now, one thing about machine learning is this: a data in itself cannot explain itself. A data is as good as useless. And I stand to be corrected, and I can say this anywhere. It is useless, it doesn't have any use. Not until we can actually, get insight from that data and unravel the pattern that is hidden, the insight hidden in that data. And that's what machine learning does. It unravels the pattern, it learns it, it studies it, and then, therefore, you can now make, after studying this, the machine learning algorithm studies this and knows the pattern in that data. And then the next thing it does is you just use it to make informed decision. Okay, based on so and so model. Okay, can you predict the sales for the next quarter? So, and it will be able to predict the sales for the next quarter, but it might not be 100% accurate. It might be in between, let's say, 90 to 95% confidence interval, which is something to work with. So that's one thing. So now, the more legit, or let me say, the more logical your data is, then the more sound your model. So if your data is not genuine and your data is just, let us say, there is lie in your data, then there won't be any practical use for any model you want to build using that data. That's something you should actually know. So now there's also model selection. And model selection is the process of choosing the most appropriate predictive model among a set of candidate models for a specific prediction task. So now, not all models you will use for a data. So there are some models that are very, very, very more useful when it comes to some certain data sets. When it comes to instances whereby you want to predict customer churn, if a customer will come back to buy your product or not. So there are some models that are actually suited for that. You get what I'm trying to say now? For example, logistic regression, we actually do justice to that. So, and there are a lot of, if it is data that has to do with clusters, then we can talk about k-means clustering. So there are a lot, it depends on the data, actually. So that's about models selection. So we have data patterns. What is data patterns? Now, data patterns refers to the underlying structures, relationships, and trends present in a data set. I say again, underlying structures, relationships, and trends present in a data set. So now these patterns can be identified through exploratory data analysis. Now, what is exploratory data analysis used for? Now, exploratory data analysis is just, you are not building models. We just want to explore. Okay, let us see. Okay, what is this data actually talking about? Do we have outliers? Okay, is this data left skewed? Is it right skewed? Okay, does it have heterogeneity or heteroscedasticity or a lot of things like that? So that's what data analysis will do. So it will actually unravel, exploratory data analysis will actually help you unravel all these things. And statistical techniques also as well. Statistical techniques like the summary statistics, like mean, the median, the variance, standard deviation, and so on and so forth, like that. So, and also such as clustering, regression analysis, and classification algorithms. So now, understanding data patterns is essential for developing predictive models. So now, this now goes down back to this. Even if you want to build a predictive model, you need to understand the data first. You allow the data, you explore the data. Okay, what is this data talking about? You can't just say, okay, I have a data, damn. Okay, now this is what I just want to use logistic regression, yeah, and you just start going. You know, that's why some of us, when we build machine learning models, you see that we hang and we just see when we run our Python script or R script, you just see that you just run into errors. Just be giving you errors and you start prompting chat GPT or looking online for different solutions and there's nothing. So, but you understanding the data now gives you, it makes you streamline your options into, okay, fine, this is the data. This is what the data is about. So I think this is the best algorithm to use. This is the best algorithm to use. Before you know it, you see, you just run your codes seamlessly and there will be no issue. So that's just the thing about that. So am I communicating? Are we following?
Yes, sir.
Yes, you are.
Yes,
Okay.
sir.
Yes, we are following, sir.
So now another thing is to notice overfitting and underfitting as well. Now, what is overfitting? Overfitting occurs when a predictive model learns noise or random fluctuations in the training data instead of the underlying patterns. And there can be a lot of reasons for that. Number one is outlier. Yes, we can have outliers there. So if there are outliers, then it can actually create noise or random fluctuations. So outliers are extreme values that doesn't add any value or that doesn't explain the pattern in the data set. So that's what we must actually watch out for. For us to avoid overfitting, then we must actually do exploratory data analysis where we have a box and whisker plot where we can actually see and note if there's any outlier and we can actually remove that outlier away so that our model can be robust. So, and the thing there is that if as a result the model will not model performs well on the training data but fails to generalize to new unseen data, it will learn what is there. That's one thing about machine learning algorithm. It will learn whatever it wants to learn, but it will not be able to generalize for a new and unseen data. As you introduce something to predict, so it will not be able to give you a higher accuracy. So overfitting can be mitigated by simplifying the model or using regularization techniques to penalize complex models. There are a lot of things that actually entails with that. So we'll go into underfitting. Underfitting occurs when a predictive model is too simple to capture the underlying patterns in the data. As a result, the models performs poorly on both the training and test data sets, failing to capture the relationship between variables accurately. So underfitting can be addressed by increasing the model's complexity or using more sophisticated algorithms that can capture complex data patterns. So now, feature engineering, which I was laying more emphasis on. So we need to spend more time on feature engineering. Feature engineering is the process of selecting, creating, or transforming features, which is the input variables in a data set to improve the performance of predictive models. So it involves identifying relevant features, removing irrelevant or redundant ones, and creating new features that better capture the underlying relationships in data. So effective feature engineering can significantly enhance the accuracy and robustness of predictive models. So that's that. Now, for the literature review, so if you want to, I won't bore us with this. There are a lot of exhaustive, write up here just to actually tell us all about machine learning itself and predictive modeling. So, and here I took my time to explain a lot of things, what machine learning is. So now we need to clear something. Machine learning is not the same thing as artificial intelligence. Please take note of that. So machine learning is just a subfield of artificial intelligence that uses algorithms to learn from data and make predictions or decisions without being explicitly programmed. So that's just what machine learning is. That's just it. So that's that about that. Now we have types of machine learning. Now, machine learning is a branch of AI, and it enables computers to learn from data and improve their performance without explicit programming, just like I said earlier. So, and there are some basic types of machine learning, which we have the supervised, unsupervised, and reinforcement. So now under the supervised, we have the regression, we have decision tree, random forest, and classification. So under regression, we have linear, polynomial. So and there are a lot of other ones there under regression. So we have under classification, we have k-nearest neighbor, we have decision trees, we have logistic regression, maybe support vector machine. So and the likes of them. So under the unsupervised, you have the which is basically clustering. So we have the SVD, you have PCA, and we have k-means. So and under the um, unsupervised, we have association analysis, which is a priori and FP growth, and also have ED Markov models. So now for clustering, this is continuous, and for association analysis, we are and the Markov model, we have they are categorical. So in that sense, so and we talked about supervised learning here. So what supervised learning does is just this. It's very simple and straightforward. So it's a type of machine learning that uses labeled data set. When we say labeled data set, it means that you already know what all those things are. Just like um, say we have labeled data sets which have both input and output variables. Like we are going to, okay, we already know that we want to train something to be able to predict if this is 5 naira. So we need to first we need to label our data set that, okay, this is 5 naira, this is not 5 naira. So that our ML algorithm, will be able to learn, okay, this is 5 naira, this is not 5 naira. So when you see this, you should be able to predict based on an unseen data with the data that we have used to train you that, okay, this is 5 naira and this is not 5 naira. So which means that we are using labeled data set. An example of that is regression analysis. And under we have linear regression, where everybody knows about linear regression. Something is a trivial model. We have polynomial regression as well. So we have also decision tree. So is a powerful tool in supervised learning, offering intuitive representation of decision-making process and facilitating predictive modeling across diverse domains. So this is it. I really gave a lot of read up and a lot of articles that has been cited. Actually goes into all this very well. So and the
Hello,
advancement. Hello,
hello,
sir.
hello. Yeah, well done. Please, at this point, let just borrow me like 1 minute. Please, because of what we are using the Google Meet. So that is why the internet has not been disrupted from my hand here because I'm the one recording. So I would like to say that less than 10 minutes now, this recording will lapse and all of us will go off, and a new link will be sent to the group immediately so that we can all come back for the rest 1 hour. So this link will go for only 1 hour, and that 1 hour is remaining about less than 10 minutes now. So please, if you need this one lapse, I would like us to wait for about 1 or 2 minutes. I will share another link in the group, and all of us will come back again and continue from where it lapses. Thank you. You can continue, please.
Okay, sir. So now what we did here was try to talk exhaustively on different machine learning algorithms. So which we actually did here. We talked about random forest, what it is and what it is not. So and I would want us because now like I said, this work is this training is more practical, and what I want us to do is that I want us to take our time after the uh, tonight's class, can go through it, read through it, and actually we are going to get one or two things, and it will actually help us. And we are going to see the reasons for choosing some particular machine learning algorithms, why you need to choose them and why you need not to choose them. So, because of our time, I won't be able to go into this. So, these are explanations on different algorithms. So, if you will have any questions, that means I can
Please,
maybe
hello,
tomorrow.
coordinator.
Yes, sir.
I would not like you to say you won't go through it. Please, you have to brush through it and tell them the condition for the application of each of the algorithms. Or is it until we get to the practical where you can now state the conditions?
Yes, yeah. When we get to the practical,
You will
so
now
that's
state
why
the
I don't want to.
conditions. Okay, all
Yeah,
right,
which is the
all
chapter
right,
three
all right,
aspect.
all right.
Yeah, chapter three and
That's
four.
good. That's good. Okay, all right.
Question.
Okay, so now this let me start from here. So now we're going to look at predictive model. The other section that we just left just now is based on explaining, giving a novelty to all the machine learning algorithms, both the supervised and the unsupervised ones. So, and which we are going to look into when we actually get to the practical side, because there is a there's a Jupyter notebook that we are going to look into together, and there is a data that we're going to analyze together, and that data itself, we are the results that was gotten from the data is actually here, so to say. So, and it's been documented, the accuracies and everything. Like I said, we used 11 machine learning algorithms. Yeah, that was all we used. So, and I'm going to look at that. So now, like I said, so now we want to set something straight from the topic we're discussing now: predictive model, machine learning, selecting best fit based on data patterns. So, for what is predictive model? Predictive modeling stands as a transformative process wherein data and sophisticated algorithms intertwine to unveil insights and anticipate future trends or behaviors grounded in historical and current data patterns. So that's what predictive model is about. So it allows us to, actually make use of machine learning algorithms and historical data. We actually intertwine them. That's the interaction where we use the algorithm on the data. Then what do we get? We get a predictive model, and then so that we can uncover future trends and patterns. So now the thing there is that it serves as a cornerstone in decision making across diverse domains. So not only in the academia, it's different domains. So harnessing the power of data-driven insights to illuminate pathways forward. So, and now I want to go into predictive model process. Now we need to know something. Now you need to put something at the back of your mind. If you want to build a predictive model, or you want to build a machine learning model, there are some things you need to know firsthand. Now the processes are this. Number one, data collection and preprocessing. You need to know that. Number two, data splitting and sampling. Number three, model selection and training. Number four, model evaluation and tuning. Number five, model deployment and monitoring. So I'm going to explain them one after the other now. So now I want to talk about predictive model processes or the steps that needs to be followed. Now, data collection and preprocessing is very important. Now, without data, you can't build a machine learning algorithm. That's just the truth. So now, these steps involves gathering relevant data from various sources. Now, in quote, relevant data from various sources such as databases, surveys, that's from questionnaires, databases like online databases or repositories, different repositories. So it can be surveys, administering questionnaires, collecting your data firsthand from the field, from sensors, Now, when we talk about sensors, that means that these sensors basically, this type of data actually is being used specifically in deep learning. Well, I won't go deep into that for now because we are not talking about deep learning now. Or web scraping. Now, the one that is most especially um, very common is database. For example, we can see data in Kaggle. Yes, there are a lot of data sets in Kaggle. Yes, and that's where most of the data scientists and data analysts use. That's where you see them. But in the academic sector, we most especially we do surveys, and in most some companies they use secondary data sets, or they also do surveys as well. So, and one thing there is this is that data preprocessing may include tasks such as cleaning, which is very important step in building a predictive model, filtering, scaling, encoding, imputing or aggregating the data. So that's step one, data collection and preprocessing. Very important and very vital. Now, the step two is data splitting and sampling. Now, this step, it involves dividing the data into two or more subsets. Now, such as the training, validation, and testing sets. I know we must have heard about train test split before. That is when we are building my ML models, train test split. So now, why do we need to split our data? There are reasons for splitting data. Number one, 100% of my data, I actually need to split it into 70-30 if it is just for training and testing. The reason is because, number one, I want to know if the model I want to predict model I want to build, if it's going to perform well based on the underlying pattern that the algorithm has unraveled or has learned during the process of the training. So I need the remaining 30% out of the 100% to actually test the model itself, if it performs well. So that's just why we always do data splitting, where we split into two or three parts, where we also have validation aspect. But the one that is mostly common is training and testing. But where validation is being used most especially is that's training, validation, and testing is in deep learning. It's very common there, very very common. So now to avoid overfitting and evaluate the performance of the model, that's why we do things like training, validation, and testing sets. So data splitting and sampling may use techniques such as random sampling, stratified sampling, cross validation, or bootstrapping. So which we will see on the longer run with the data that we want to actually analyze. So we also have model selection and training, which is the third step now. So after you have collected your data, one, and you have processed your data, the next thing you do is split your data into the test, the train, and validation. So where we can say 70-20-10 or 80-20 or 70-30. The one common is 70-30. So now, for the model selection and training, these steps involve choosing an appropriate predictive model based on the type and characteristics of the data and the problem. So now, there are many types of predictive models, such as regression, classification, clustering, time series, decision tree, or neural network models. Now, going into deep learning. But model training involves fitting the model to the training data using a learning algorithm such as gradient descent, Bayes